Chancellor, distinguished guests, it's my difficult job, I think, to tell you about all of Mario Molina's achievements. You've already heard a lot about them, and our President already told you some of his achievements and honors. I thought I would tell you a little about the man and the context in which he worked. Jose Mario Molina Pascual Enriquez was born on March 19, 1943, and raised in Mexico City. Seemingly, he was always interested in chemistry. He had apparently a laboratory in his spare bathroom as a child. He gained a degree in chemical engineering in Mexico, then went to Fribourg and Paris for postgraduate courses. In 1968, he went to University of California, Berkeley, to do a PhD, and I think that was a pretty exciting time. Perhaps he'll tell us over dinner. That was the time when all the protests were on, certainly. He joined a research group led by Professor George Pimentel and worked on chemical lasers. He graduated PhD in 1972, and the following year started a postdoctoral position with Professor Sherwood Rowland, or Sherry as is commonly termed. But what were they going to study? I want to take you back about 30 or 40 years before that, several decades, to a man who was described by McNeill, who's an American historian, as a person who had the greatest impact of any organism on the environment. His name was Thomas Midgley. And Thomas Midgley, first of all, invented lead in petrol and did us all a great disservice. His next effort was to work for Frigidaire to make Freon. And Freon was the first CFC, dichlorofluoromethane. Now, CFCs were a miraculous chemical. They were for food safety. We could store vaccines in Africa. Fridges prior to then exploded and poisoned people. So they were a fantastic, stable, and inert compound. At peak, the world was producing 1 million tons of CFCs a year. But in a way, their stability was also their problem. In 1972, in Nature, a paper identified CFCs in the northern latitudes where they were being produced in the atmosphere. So Sherwood Rowland had gone to a conference. I think he came back and said to Mario, we're going to do CFCs. That's what we'll do in the atmosphere and look at their impact. And they started working in atmospheric chambers. This was, don't forget now, 1973, I think. And within a few months, it became obvious that they discovered a potential environmental disaster, that CFCs, through the release of free chlorine, could break down stratospheric ozone. Sherry Rowland famously wrote to his wife, "The research is going well, but it could mean the end of the world." You see, ozone protects the world from excessive UV exposure, and depletion would have major effects on animal, human, and plant health. So their scientific discovery, or their hypothesis at that stage, would have had a major societal impact. They published their landmark paper in Nature 1974, and I don't often read out abstracts, but I thought I would because it's absolutely on the money and it's not a spare word in it. What they said was, CFCs are being added to the environment in steadily increasing amounts. These compounds are chemically inert and may remain in the atmosphere for 40 to 150 years. Concentrations can be expected to reach up to 30 times present levels. Photodissociation of CFCs in the stratosphere produces chlorine atoms and leads to destruction of atmospheric ozone. Absolutely precise and absolutely true. I asked Mario, I saw him in November at the 25th anniversary of the Montreal Protocol, and I asked him, what happened? You know, surely it would have made a big splash, little news stories. He said nothing, actually negligible. Nobody took much notice. You know, invisible chemicals, invisible gases, invisible layer. Except the chemical industry, they took notice, and DuPont especially, who poured ridicule and made huge efforts to discredit the research. Sherry Rowland said that he never gave a lecture in the next decade in a major American university because of the success of that campaign. But Mario and Sherry carried on their policy lobbying, and their hypothesis gained credence. And for that, people started to put early controls in place. It was more than a decade later, in 1985, that the Arctic ozone hole was discovered, much larger than people thought. We thought maybe 5%, 10%, but no, 50% loss of ozone over the Antarctic. And Professor Molina's team, along with others, identified that this was due to the very cold polar vortex over the Antarctic. In the Antarctic winter, ice crystals form, and they form a catalytic surface that encourages ozone breakdown by free chlorine. So another contribution. I'm pleased to say that the ozone hole was discovered by Joe Farman, who sadly died this year, at the Arctic and Antarctic survey, UK Antarctic survey. The Americans had been looking for the ozone hole and indeed missed something the size of the United States. They'd been looking for it with satellites whose computers were programmed to exclude very low levels. So they couldn't find it because they weren't planning to. The discovery accelerated political action. The Montreal Protocol for the protection of the ozone layer was signed by 20 countries who agreed a 50% reduction in CFC production just 2 years after the discovery of the ozone hole in 1987. It was accelerated through a number of amendments, and the importance of the political process is underscored by the fact that Margaret Thatcher, don't forget, a chemistry teacher, enlisted Ronald Reagan, and they both drove this through. It's now the most successful environmental protocol. What you may not be aware of is that the Montreal Protocol, besides saving the ozone layer, which it will do in time, also has been critical for climate change. CFCs are one of the most globally warming gases, and to put millions of tons in the atmosphere irreversibly would have already caused the world to be several degrees warmer. So control of chemicals, globally warming chemicals, is really important. CFCs were phased out in developed countries in 1996, and the last CFCs will probably be used in China in 2015, but we're down to the last few hundred tons now. The important message is that because of the long CFC half-life, the ozone layer will only recover by 2060. Skin cancer rates will not normalize until 2100. So an environmental insult 30 or 40 years ago is going to have an impact 100 years hence. What is true is that without Mario and Sherry Rowland's early discovery and lobbying, it would have been so much worse. In 1989, Professor Molina moved to MIT and then to 2005 to San Diego, and he now divides his time between San Diego, where his laboratory investigates the chemical properties of atmospheric particles, and his native Mexico City, where I think, having seen the students today, you'd realize he really is a hero, where he created a Center for Strategic Studies in Energy and Environment, working on improving the notoriously poor air quality in the capital. You'll have heard from our president that he serves as an environmental advisor to President Barack Obama, and he received the Medal of Freedom, which is the United States' highest civilian honor. Along with Sherwood Rowland, who sadly died last year, I would recommend you read the New York Times editorial. It's absolutely fascinating and really very rewarding read. Professor Molina received the 1995 Nobel Prize in Chemistry for, and I quote the citation, "contributing to our salvation from a potential global environmental catastrophe." So it's with a good deal of humility and admiration that I present Mario Molina, someone who has helped to save the world once and is probably now going to try and help us to save it twice. Not only for his outstanding science, as you see, a modest man, but also for his persistent and determined moral leadership. Chancellor, I'm very pleased to present you Professor Mario Molina for the degree of Doctor of Science, Honoris Causa.
I enjoyed the lecture a lot before as well. Mario Molina, by virtue of the authority invested in me by the university, and with great personal pleasure, I confer upon you the degree of Doctor of Science, Honoris Causa.